Hello, my sweet and precious children. I'm so glad that you're joining me again. So far, we've gone through 6 lessons in pre-algebra. I know you're super pumped and super excited for what we've been doing. I can't wait to meet with you in class and talk a little bit more about what you've been going over. But for today, what I want to talk about are multiplying and dividing decimals, and maybe a little bit of estimation and rounding in there as well. Now, I've kind of gone over these in a few other lessons previously. However, I need to go over some a little bit more in depth, okay? First, we're going to talk about multiplying, and you may see that especially since you guys are homeschooled, your parents may have been helping you with learning multiplication, and there is a different way that as a child I learned, that your parents probably learned, and now we teach it a little bit differently. So there's 2 methods for multiplication. Both have their values, both are totally fine. I like that second method that I'm going to introduce you to today because when we get into polynomials and more algebra, it actually makes a lot more sense for keeping things organized. However, I don't care how you multiply as long as you do it, okay? And I just need to see a little bit of your work to know that I know how your brain is functioning. Okay, so what we're going to do, if you're following along at home and you're not in my class, we are in the Saxon Algebra 1/2 3rd edition book. Today we're talking lesson 7, and that begins on page 27. Our first example that we have is multiply 4.12 times 63 and 2/10. So 4 and 12 hundredths, 63 and 2/10. And I'm so terrible about this. I always say like 4.12 and 63.2. You'll find that actually as an adult, you'll probably say it more like that, even though in the last lesson I was harping, hey, you got to learn your tenths and your hundredths. Either way is fine. Just make sure that you learn those. Okay, with multiplication, with decimals, you actually just treat it like a normal multiplication problem. You just ignore the decimals till the very end. So really what this problem is, that is totally my fire alarm, and I don't know how to pause this. Okay, so that's delightful. I'm gonna pause this and figure out what's going on. Okay, fire alarm is done. Sorry about that. Wasn't actually a fire, smoke detector. Okay, so as I was saying, we're going to treat this like a normal multiplication problem. 412 times 632. 632. Also, if you hear panting in the background, it's my dogs. God, I'm a professional, I promise. Okay, so taking a look at this guy, we have 412 times 632, right? Times 632. That's a 3 by 3. So what we're going to do is we're going to draw a 3 by 3 box. Looks like this. I'm terrible at drawing these. I don't know why. Math teacher. I'm supposed to be good at drawing. I'm not. I actually bought stamps, so I don't have to draw geometry shapes anymore. Okay, 412. It doesn't matter if you put it on the side or on the top in any order, because we're allowed to multiply in any gosh darn order. That's going to be 400, 10, and 2. 400 plus 10 plus 2 gives us 12. 412. 636. Oh my goodness. 632. Let's try that. 630 and 2. Excellent. Okay. What we're going to be doing is multiplying each of these and putting them into that nice little box. So 6 times 4 is 24, plus we have 1, 2, 3, 4 zeros. And I'm going to use a little comma just to keep things nice and clean, okay? 3 times 4 is 12 with 3 zeros. 4 times 2 is 8 with 2 zeros. 6 times 10 is 6 with 3 zeros. 3 times 10 is, or I'm sorry, 3 times 1 is 3 with 2 zeros. 2 times 10 is 2 with a 0. 2 times 600 is 12 with 2 zeros. There we go. 3 times 2 is going to be 60, and 2 times 2 is 4. All right, so let's add all these guys up, right? I'm going to combine as I go along, and the deal with this is it seems like it's taking more time right now, but as you get faster at it, it becomes much faster. So as you practice, you get more fast at it. I'm going to combine these two first, right? So that's going to give me 252,000. 252,000. Okay, then I have these two guys that I can combine. That's 7,200. Then I have these two guys I can combine, which is 1,100. And if you need to list them all out to add them as you get used to it, that's totally fine. 60 plus 20 is 80. With that 4, that's 84. 84. So we're going to go ahead and add these guys. When we do that, we get 4, 8, and then we get right here is a 3, 7, 8, 9, and 10. Carry the 1. 5, and then that's going to give us 26. Okay, so we have our number. We have to go back to the original problem now, and we look and we see that what we're looking for are digits that are behind decimals. So we have 1 right here, and then we have 2 and 3. So 3 total digits that are behind decimals. We come back to our number, we go 1, 2, 3, make those lovely 3 bunny hops and put our decimal in. We always start at the end once we've done the math part of it. So that means our answer is 260.384. Excellent. Okay, so now we're going to talk about division. Okay, so for division, let's look, I'm now on page 28 looking at 7.3. We want to divide 0.084 divided by 0.35. Okay, first things first, this guy that is in the front goes underneath our table, 0.084. Then right here, this guy goes on the outside of the table, 0.35, okay? Now what we're gonna do is, we can never have a decimal on this side of our division problem. So we're gonna need to get rid of that decimal by making it a whole number. In order to do that, we're going to do 1, 2, that gives us a whole number, right? 35. But if I do it to one side, I have to do it to the other, right in here. So I moved it 2 spots, so I'm gonna move it 1, 2 more. I end up with 8.4. I don't know why this isn't focusing, I'm sorry guys. Okay, so, let me try this. No, definitely won't do that. Okay, I'll fix it for the next videos. Sorry guys, be patient. Thank you, my sweet students. Okay, maybe that'll work. Okay, so back to our math here. Now that we've gotten rid of the decimal on this side, we're allowed to have a decimal here, but what we do with that decimal is we bring it up. If there is no decimal in a number, remember it's at the very end, okay? So this works with completely whole numbers too. All right, 35 goes into 84. Let's try 2 times. Let's do some side work here. 35 times 2 is gonna give us 0, carry the 1, that gives us 70. That actually seems about right, because if I did 35 times 3, it would be over 100, right? So we're gonna do 2 times, right? It doesn't go into 8, it goes into 84, so you need to line that up nicely. 2 times 35 gives us 70. At this point, we subtract, and every time we subtract, we bring down. You may ask what we're bringing down since there's nothing there. We have a number for nothing, right? That number is 0, okay? So let's subtract, we get 6, and we bring down, let's try that again. I don't know what I'm doing with my subtraction. I was looking at that totally wrong. Okay, so we get 4 and 1, and we bring down a 0, right? So we have 140. Well, 2 is 70, and we know 70 times 2 is 140, right? So let's try 35 times 4. I bet that'll work. So 5 times 4 is 20. We carry that. 3 times 4 is 12, plus 2 more gives us 140. Excellent. So we come over here, we say 4. 4 times 35 gives us 140. We subtract, we have no remainders, we have solved this problem. We come back up here to our original and we say, bam, this is 0.24 or 24 hundredths. Excellent work. Okay, so I'm gonna do the next example, which is 7.5, because like I said, when you have whole numbers, this method works as well. So for 7.5, it's asking us to take 31 divided by 8. 31 divided by 8. Well, we know that this guy goes underneath our table, right? So we have 8 divided by 31. All right, where is the decimal in this? Again, this is part of our silent math or our invisible math. It's at the end, right? So we don't have to fix the decimal here because it's already fine, but we do need to do our division now. So 8 goes into 31 how many times without going over? Well, we know 8 times 3 is 24. 8 times 4 is 32, right? So it can't be 32, it's gotta be our 24. 8 times 3, that gives us 24. If we go ahead and subtract, we get 7 here, and if you need to borrow and do this, right, you can do that. So we get 7. Let's bring our decimal up here. We could say 3 remainder 7, but that's very lower grade math. That's lower grades do that. Now that you're getting into algebra, we've got to do some extra work, okay? So instead of this decimal, we have a 0 after it. Not instead of, after the decimal we have a 0. So whenever we subtract, which is what we did here, we always have to bring down. So now we're asking, how many times does 80 go into 70 without going over? Well, we know 8 times 10 gives us 80, right? So what's 8 times 9? Well, that's 72. That's over 70. So let's try 8 times 8, which gives us 64. So let's try 8. 8 times 8 gives us 64. Excellent. Okay, so we go ahead and subtract that. We get 6, and every time we subtract, we bring another 0 down. Excellent. Okay, so now we've got 60. So let's see what we've got. Oh, how did I do that? You guys, I made a math error, didn't I? No, we're good. We're good. I'm sorry, I was looking at the wrong problem. Holy cow. Okay, so we've got 8. So we brought down our 60. How many times does 8 go into 60 without going over? Well, it can't be 64, so we're gonna do 8 times 7, which is 56. That's where I messed up, sorry, I thought I made a mistake. 7 times 8 gives us 56. And now we subtract and we get 4, and every time we subtract, we bring down another 0. Now, sometimes this can keep going on for a while. I suggest you do it to 1, 2, 3 decimal spots after and then stop, okay? So, how many times does 8 go into 4 without going over? That's perfect, it's 5, right? 5 times 8 is 40, and we are done with this one. We are done. So our answer is 3.875. 3.875, excellent work. Okay, so that's dividing decimals, right? Excellent. Now let's do, okay, so occasionally you will see, or actually what is a really good habit to get into when you're dividing and multiplying decimals is to round things to a number that you're able to deal with to see if you get an answer that's close to you. For example, if I gave you 4.12 times 63.2, okay? We could pretty much round these numbers. Let's round that to 4 because 0.12, right? It would round down to 4, not up to 5. 63.2 would round down to 63, right? 63. So if we were to multiply those two, we would get 63 times 4, 2, carry the 1, we would get 24, 25, 252, 252, okay? So let's keep that in mind as we do the actual math problem right here. All right, so if we do, and this was actually the problem we did at the very beginning. That's why I'm like, this looks familiar, right? And if we recall back, if you look back in your notes, the answer that you got was 260.384. 260. Is that close to 252? Yeah, reasonably close enough considering that we did we definitely did some estimating, okay? So this is a good way to make sure that you've got the right idea, okay? All right, so there are, on page 30, there are 4 practice problems. We're gonna go through those. All right, so for A, it says estimate and then find the value of 44.612 times 2.14. Go ahead and pause and give this one a shot and then rejoin us. Okay, so I would estimate these to be, that's about 44, right? This would be about times 2. We can do that in our head. 44 doubled would give us 88. 88, okay? So now let's do the actual math part of it. So we have 44,612 times 214. This is gonna be a big one, guys. This is why I like doing the table math, right? We said this is about, I'm gonna write this up here so that I have that guy. Okay, so this is why I like doing the box method, because it leaves, yeah, it's a little bit easier. So we've got a 5 by 3. So here's our 5. 1, 2, 3, 4, and then we've got by 3. All right, up top here we have 40,000, 4,000, 600, 10, and 2. All of that adds up to this. Then we have 200, 10, and 4. Okay, so now we got some math to do. 2 times 4 is 8 with 1, 2, 3, 4, 5, 6 zeros. That gives us 8 million. Whew. All right. 4 times 1 is 4 with 5 zeros. Put a little comma in there. 4 times 4 is 16 with 4 zeros. 4 times 2 is 8 with 5 zeros. Okay, 1, 2, 3, 4, 5. Yep, just making sure. 4 times 1 is 4 with 4 zeros. 4 times 4 is 16 with 1, 2, 3 zeros. 6 times 2 is 12 with 4 zeros. 6 times 1 gives us 6, 1, 2, 3. 4 times 6 is 24, 1, 2. This is going to be 2. 200 times 10, which is 2 with 3 zeros. 10 times 10, which gives us 100. 4 times 10, which gives us 40. This gives us 400. This gives us 20. And this gives us 8. All right, so we've got some combining to do here. It looks like 800,000 and 400,000 would be 1,200,000, which is 1.2 million. So I'll write that down. We have 800,000, right? Or 8 million, I'm sorry. And then this plus this, 8 and 4 is 12, right? But we have all these zeros that we have to deal with. Okay, so let me make sure I got that right. Oh, I did see it. I knew it. It's 1.2 million. Okay, 1, 2. So that's those two. Let's cross those out, right? Then we've got 160. That's that guy. And then we've got this and this. We can combine to be another 160. And then we've got 16, and this is going to give us 22. All right, so what we're going to do right now is add all these guys up, and then we'll deal with these little ones, okay? So we got a bunch of zeros, 1, 2, 3. And then on this, we've got 2. Then on this one, we have 12 plus 2 more is 4, carry the 1. And then that's going to give us 1, 2, 3, 4, 5. And 9. Okay, so we've got that guy, right? I'm going to write that down. 9, 5, 4, 2, 0, 0, 0. This is just because my whiteboard's so small, so I apologize. And like I said, you can do this the other way too, where you line everything up, but it's up to you. We won't have this many difficult questions on the problem. This is a huge one. Okay, so then we've got all these guys that we have to add up too, right? So we have this plus this is going to give us 4,400. So 4, right? That's this and this guy. Then we have 100, that's 500, 40, 50, 60, 8, 568. You see how I did all that? Okay, so now we've got these. We've got 8, 6, 9, 4, 5, 6, 6, and then we carry the rest of that down. All right, so that's our answer. Whew. All right, then what we do is we count the digits that are behind decimals. We have 1, 2, and 3. 4 and 5. There are 5 digits that are behind decimals. So we're going to come over here and we're going to go 1, 2, 3, 4, and 5. We get 95.469668. Excellent. All right. So that was problem A. And I promise there won't be any that are that difficult. Let's just double check. Excellent. We did it right. Whew. I'd hate to do this whole thing and then be like, oh, we got it wrong. All right, that was A. Okay, so for B, this is going to be another long one, guys. 5.22 times 0.064. A part of that invisible math, by the way, is that I just dropped that zero. That zero that's in front of the decimal. That's totally fine. You're allowed to do that, okay? This is going to be a 3 by 2. Because if I take these decimals away, what I have is 522 times 64. That's what we're basically looking for. So 3 by 2. Much better than a 5 by 4, whatever that last one was. Okay, so we got our 3. And we have our 2. So we have 522 and 64. This times this is 30 with 1, 2, 3 zeros. 2 times 6 is 12 with 2 zeros. 2 times 6 is 12 with 1 0. 5 times 4 is 20 with 2 zeros. 4 times 2 is 8 with a 0, and then 4 times 2 is 8. I realized I pointed to those as I said them backwards. Okay, so we have 30,000. Then we have 1,200. This has a comma right here. Plus that is going to be 3,200. That's these guys. This plus this gives us 200, and that is 8. So plus 208. So we add those guys together, we get 8, 0, 4, 3, and 3. There is our answer, but we're not done because we have to do the decimal part. So we come back up to this original problem and we look at digits that are behind decimals. We have 1, 2, 3, 4, 5 are behind decimals. So we come back down here, our decimal is all the way down here. We go 1, 2, 3, 4, and 5. Our new number is 0.3340.8. Excellent work. Any questions on that? Let me know. I'll be happy to help. All right, so for C, we have 43.24 divided by 0.027. If it's on top of the table, oh, so there we go, focus in. All right, so give it a pause, make sure you do this problem. Remember that if, and then come on back, if it's on top of the table, it goes underneath the table. So we have 43.24 divided by 0.027. We need a whole number here, not a decimal, so we're going to bring that decimal 1, 2, 3 spots over. If I do it there, I have to do it on the other side. 1, 2, what do I do now? I add a 0. 3, there's my 0, okay? So what I really have is not 0.27, it's just gonna be 27 divided by 43240. 43240. Let's do some math over here. 27 times 2, we know 27 times 1 is 27. 27 times 2, that's 4, carry this. We get 2 times 2 is 4, plus 1 is 5. Okay, so 27 does not go into 4. You can put a placeholder there, a line, a 0. I'm gonna put a little 0 just so we remember. But it does go into 43 one time without going over. If it went 2 times, it would be over, right? So 1 times 27 gives us 27. We subtract. Make that a 3, make that a 13. That's going to be 6. And then 3 minus 2 is 1. Every time we subtract, we also bring down. So we get a 2. All right, how many times does 27 go into 62 without going over? Let's try this. 27 times 4. This is going to be 8 with a 2. That's going to be 8, 9, 10, 108. Let's try 27 times 5. That's going to be 5 with a 3. 5 times 2 is 10, plus 3 is 135. Let's try 6. 6 times 7, that's 42. This is 12, plus 4 is 162. Excellent work. Okay, so 6. That goes above this guy. If it helps, you can draw little lines like to keep you nice and organized, right? That sometimes helps some of my students so that you can see and that you're going in order. You're totally welcome to do that. All right, so 7 goes in, so 6 times 7 gives us 162 minus, okay? We get a 0, every time we get a 0, we bring down. Now, does 27 go into 4? Sure as heck does not, so you just throw a 0 here and you bring another 0 down. Does 27 go into 40? It sure does, one time. 1 times 27 gives us 27. If we do the math on this, we get 3, 10, we get 13. Does 13 go in? Oh, and now this is our decimal here, and we've brought our decimal up to here, right? So does 27 go into 13? It sure does not, so we throw a 0 in there and we bring another 0 down. Now, does 27 go into 130? Sure does. It looks like it goes 4 times without going over. 4 times 27, which we did over here, is 108. 108. So what we'll do is make that a 2, make this a 10. We end up with 22. 22, okay? At this point, you can stop going. You really only have to go to this. You might want to do one more, but as long as you get to the 100th, that's usually pretty fine, okay? Any questions on that? Let me know. All right, so then we've got for D. 52 divided by 18. 52 divided by 18, okay? On this guy, remember this is in the front, so it goes underneath our table. And then over here, we put our 18. Now we're gonna need a reference of 18s. And if you don't have one, I highly recommend that you get a multiplication chart that goes 20 by 20, so that you've got something that looks like this. Let me get my marks off here. Something that looks like this. Do you see it's a 20 by 20? We go 20 to here. That'll be helpful because what we're gonna need is our 18, right? Our 18 I'll underline. So that's gonna be this guy. All right, so how many times does 18 go into 52 without going over? Looks like it goes 2 times right here, if you can see that. 2 times 18 gives us, on our little chart here, 36. Let's go ahead and do the math. That becomes 12, that becomes a 4. We get 1, 6, excellent. And now we have our decimal here, so we need to bring our decimal up to here, okay? Does 18 go into 16? It sure as heck does not, so we have to bring down another 0. Actually, I'm sorry, I shouldn't have said it that way. We subtracted, and therefore, because we subtract, we have to bring down a 0. Forgot that part, sorry. Okay, so 160, does 18 go into 160? Let's take a peek. It goes into, if we go 9 times, that's over, so let's do 8 times, and that's 144. 8 times 18 is 144. Okay, we're gonna go ahead and minus that guy. This becomes a 5, this becomes a 10, so we end up with 1, 6, 1, 6. Since we subtracted, let's go ahead and bring down another 0. Now, does 18 go into 160? I feel like we've just asked this question. It sure does, and when we get that, we get 144, right? I feel like this is gonna keep going on forever. Do you see the same pattern? That's because what we're gonna do is, I'm sorry, let me just double check. Yep, perfect. So, okay, it does keep going on forever. I wanted to make sure we did that right. So what we're gonna do is we're gonna come back up here, and the 8 is what repeats, so we actually didn't even need to do this other 8. You put a little line over it like this. That means 2.8 repeating, 2.8 repeating. Now, if I did like this, 2.18, just an entirely different number, and I put my line over the 1/8, what that is saying is that that 1/8 repeats. So it goes 2.181818, okay? If I did it like this, and I put my line over this 8, what that's saying is 2.18888. So get those lines, make sure you understand what those lines mean. But for this answer, 2.8 with a line over it's perfect. 2.8 with a line over it. Okay, that should be all the practice problems. If you have any questions, let me know. Excellent work, thank you.